Good morning. It's me, Mr. Truman, back again for another installment of geometry. Quick lesson today. It's not going to be too long. We're just going to go over one concept today called vertical angles. And this is kind of the third installment of some special angle pairs that we've gone over this week. We had complementary angles that were two angles adding up to 90 degrees. We had supplementary angles, which are two angles that add up to 180 degrees, which also most likely will be linear pairs because they normally are adjacent to each other, but we'll get a little bit more into that as it comes along. And then we have today what's called vertical angles, which are two angles that are congruent, and they are formed by taking two lines that intersect. So whenever we have two lines that go across the page and they intersect like this, they immediately make something called congruent angles, and we call them vertical angles in this case. So let's look at our first problem here, and it says list the congruent angles in that diagram. So the things I want you to know about this when you look at this diagram is that the angle right here and the angle right here, you can look at those two and you say, gosh, those look like they're the same angle. Well, they are. They're the exact same measurement. That's because they're vertical angles caused by those two lines intersecting. Just like these two angles are also congruent. So what I've asked you to do in the first example, or what I'm going to do in the first example, is I'm going to list the angles that are congruent according to the diagram. So in this one, I notice that I have an angle here, and I'm going to give it a name, and I have to use the three-letter naming system because these angles are not standalone. They are sharing sides with other angles. They're adjacent to other angles. There's linear pairs here. I need to make sure that I use the three letters. So the only key on that one is to make sure the vertex is the middle letter when you list it. So our vertex is at B. So I'm going to call this one angle ABD is congruent to, and don't forget I could call that ABD or DBA, same thing. Over here, CBE. And if you call it EBC, you're still right, it's the same thing. All right, these two are congruent. I don't know what their measure is, but whatever it is, it's going to be the same for both sides. Now, same thing goes for here and here. I know that the angle at the top, let's call it ABC, is definitely going to be congruent to DBE. And just don't get hung up on the names. Just as long as you keep B as the vertex, or know that B is the vertex, then B is going to be in the middle, you're set. Okay, let's apply this to solving some problems that we normally see in geometry. Use this concept and use it to go forward with a problem. So let's look at example number 2. I have a line L. I use the old one-letter naming system where they use a lowercase cursive letter. Line L and line M are intersecting, which means they are forming vertical angles. So I know from this lesson that this is 48. That means that Y has to be 48. So I can write down that Y is equal to 48 degrees. Now, if I think back about yesterday's lesson, we talked about supplementary angles and linear pairs. Well, this angle right here, Y, and angle Z, they form what's called a linear pair. Just like Y and X form a linear pair, and X and 48 make a linear pair. Anytime you have two angles that are adjacent to each other, sharing a side, but yet making a straight line, those are called a linear pair, and they are supplementary. So I know that if this is 48, then X, for example, X and 48, I'll just write it out as a math equation for us. X plus 48 has to equal 180. So I can just take 48 and X is equal to 132 degrees. Now I could have done this with 48 and Z, Z and 48, X and 48, or X and 48, or the Y and 4, or that one there, I'm sorry. Either one, they all gonna work out the same. So I know that X is 132 degrees. And because of vertical angles, I know that Z is now 132 degrees, and I've answered all the questions. All right, let's play this out in more of an algebraic setting. Let's look at this problem. I know that I'm looking at two intersecting lines. I can see that I have a set of vertical angles here, and I have three different variables to work on. So I'm going to start with what I have here, these vertical angles. I'm going to write down that I am fully confident that 9x minus 1 is equal to 107 because they're vertical angles. Well, if I solve that as a math equation, I get 9x equals 108. Divide by 9, x comes out to be 12. Okay, so I know that x's are 12. So if I'm solving the math problem for algebra here, x is equal to 12. And if I plug that in, 9 times 12 is 108, take away 1 is 107. But more importantly, what is this one right here? Well, I know that these two are supplementary and they form a linear pair. So if this one is z and this one's 107, let's say I choose these two, or I could choose these two, it doesn't matter. Either way, I know that z plus 107 has to equal 180. If I minus 107, I'll have z is equal to 73 degrees. And then what I also have to know about this is that y is going to be 73 degrees. Automatic. And that's because it's vertical angles. So I have one more problem that I really want to test your algebra skills and really go over a concept from algebra last year. Let's do one like this, where I have an expression on the left and I have an expression on the right. And we know that they're vertical angles, so the two expressions have to be congruent. So let's make them congruent, or let's make them equal for algebraic purposes. And then we'll come back. Well, remember, the rule is in math, in algebra, if you have variables on both sides of your equation line, you should generally make it life easier for yourself by getting rid of the smaller of those two. So I always pick, if I look at it and I say, well, I got 3 x's on the left and 5 on the right, I'm going to get rid of the smaller one first using the opposite. So I'm going to minus 3x. So I'm going to do its inverse there. You know, opposite of positive is taking away, or subtraction. The opposite of dividing is multiplying. So I'm going to cancel these out. I'm going to bring down that 6. And I've got 5x's take away 3x's is 2x's minus 10. Well, now I've got a two-step equation. I add 10, I add 10, I get 16 equals 2x. X, if I divide by 2, is equal to 8. Now I know what x's are. X's are equal to 8. Well, let's substitute that back into our math problem and see if we can figure out what it is. So let's plug in that 8. Substitute 3 times 8 plus 6. Well, 3 times 8 is 24, and 24 plus 6 makes this 30 degrees. And I'm going to be lazy. I don't have to keep working because you know what? If this one's 30, do I really need to substitute in on the right? I could, but I'm not going to because I'm lazy, and I already know that the rules say that if this one is 30, then this one is 30. I mean, I'll double check my work, of course. 5 times 8 is 40. 40 minus 10 is 30. So I'm good. I didn't have to do that. And then what do I know about 30 and y? Since they're right next to each other, they're adjacent, and they're forming a straight line together, that means they have to equal 180. Well, 180 minus 30 tells me that y is equal to 150. And then what do we know about z? Well, again, vertical angles tell me that it's 150. And that's how vertical angles work. It's going to be pretty useful for solving problems for us, and it's one of our foundation, kind of our building blocks of the school year in this class. Hope that sums it up for you. Have a great day. Bye.